And now it's my pleasure to introduce our final speaker for day 2 of the Georgia Dairy Conference. Joining us today is Dr. Miel Hostens. He is the professor of digital dairy management and data analytics at Cornell University, where his lab focuses on developing data-driven dairy science with a vision towards contributing to food production systems from a global perspective. Dr. Hostens' unique approach to data collection, analysis, and optimization has made him a leader in the space within the dairy industry. His collaborations with industry have led to the development of new tools for producers and the businesses that support them. Today, Dr. Hostens is here to discuss the advantages and challenges dairy producers now face in an age with countless data points and decision factors. Would you welcome me in joining Dr. Miel Hostens to the Georgia Dairy Conference?
Perfect. Thank you. All right, ready for the last one? I'll make it some fun. I know how to do that. That's the good thing. All right, who's that guy in front of it? He has a bit of a strange accent. I'll give you some background so you understand. Let me see. If I click, it doesn't work right now. Probably you need to just click the browser once. Yeah, click it once. Thank you. Thank you. There we go. All right, this is going to move. One of the things is there's 3 people in the room that cannot answer today. Albert, you're forbidden to say anything. Mike, forbidden. Mark, you have to shut up because there's some things that you will need to do for me today. Matt, I don't think you have seen this blog before, so sorry for that. Okay, let me introduce you. This is one of the most amazing women in my life. This is a woman called Maria Paula Minute. This is her last name. See the animal in the back? I'll give a bit of background and then you know. Born in 1924 between World War I and World War II. Had 9 children, 2 died. Went to school until she was 14. Only 1 language, which most people wouldn't even call a language. She was a smallholder dairy farm milking 4 cows by hand, some of her best cows producing 45 pounds of milk, peak lactation at, let's say, 7,000 kilograms of milk. No access to nutritional knowledge. I will tell you, the only knowledge she had about cows was the amount of cakes that you have to give a high-yielding dairy cow at peak lactation. She had no idea what was in there. Little access to genetics. I don't know if she was able to understand what the word genetics was. If you were at school until 14, that was probably very little. Little access to technology. I remember the biggest technology was a milking unit that came in at a certain moment. She did not feel responsible for the planet. She would burn everything she could find. All right? Everything. I remember when the planes came over, the helicopter, we had to hide everything that was burning because you get a fine in Belgium, I'm Belgian, for burning stuff. This was my grandmother. I was born to it. So this is me with a what? Who recognizes the breed if you come from Belgium. Belgian blues. The ones that, for me, it's more natural for a calf to be born from the side, not from the back. This is me. This is my dad. This is the breed that we had for milking. This is eventually what happened because of the introduction of quota system. Okay? This is also her land. To give you an idea, my grandmother's land is right now valued at probably, let's say, $120,000 for 2 acres. Yeah, because it's pure vegetable ground. But there's a bit of a problem because there was some German invasion at a certain moment, and you guys helped us out, but you left something. What you left is, so to give you an idea, I looked at the numbers of that region in Belgium. So we still get 3,500 calls every year by farmers who dig up bombs from World War I. That's still 10,000 bombs a year of roughly 550,000 pounds of bombs that we still have. Germany still pays the Belgian government for that cleaning. Think about what we are doing, people around the world. Think about what we are doing. Destroying agricultural land. This is over 100 years right now. All right. I was spending my holidays at my grandmother's farm. I had the first Macintosh at home. Probably I had one of the Macs at home that had Steve Jobs' handwriting in it. My mother threw it away. She trashed it. I said, what? It was probably $10,000 worth, but okay. I became a vet 2006, 12. I did a PhD, and this is completely changed in 2 generations. I have Mike Van Amberg next to me, so that's unlimited access to nutritional knowledge, access to the best cow genetics. I have technology and AI now. I'm going to talk about AI, I promise. I speak a lot of different natural languages and computer languages, which is completely different with my grandmother. I work with smallholder farms and some of the largest dairies in the world. But I feel extremely responsible for the planet. Extremely, I'll be honest. I travel the world right now, which is not really responsible maybe, but I feel responsible because I hope my kids will survive this planet. That's simple. To give you an idea, so I looked at it because people were telling, I had New York dairy farmers saying, why are you going to Georgia? There's only 2 farms over there. And I was like, so, and then I looked at it to compare it. And indeed, if I compare it to my home country, let's say, you guys have, let me see. So in Belgium, we have 6 to 7 times more people per square mile. And we have 43 times more dairy cows per square mile on top of it. So that's a kind of the difference with Georgia and where I come from. New York is completely different. I won't even start comparing right now. All right. I'm a bit of an academic entrepreneur. People have said that. So if you're working with the Milk Sustainability Center from De Laval and John Deere, my technology is in the back. I've been working on a company that integrates data. Some people that know Spade, Vila, FarmES, they are working in the back. I was just awarded, I'm going to start with a new startup, which is working on securing data, privacy preserving fusion of dairy data, and that's going to be announced. This is my hobby, my own Belgian, my own black and white. This is the only thing that I can afford. If you're a professor, you're poor. So this is the only thing what you can read. And then I used to do this at home, so I programmed. That's where I got to understand what it is like to work with data and animals. I love it. I completely love it. But now I have something new. So if you want to, this is my first introduction to dairy, let's say real life dairy, because Select Sires has a bull right now that is named after me. So if you want to have the highest polled Holstein bull in the world, you can use me right now. If you want fresh semen, there's things that we need to negotiate. Okay, but I'm also worried. And that worry is my trick that I'm going to do today. I think what I want to try to prove you is that I think you're okay, this is going to be offending, but you'll get my joke. But I think I can prove that you're probably more stupid than a bunch of chimpanzees. You see, people laugh. I'm going to try to prove it. So there's only 3 people who don't have to stand up right now. Can all of you stand up, except for the people that, can you do that? You have to stand up. And I want to prove that you're more stupid than chimpanzees. All right. Uh-oh. What is he doing, this strange guy? Okay. And you'll get it. If you think that the answer to this question, what is happening at this moment with the number of cows in the world, if you think that it's declining by 10 million cows per year, you can sit down now. So you guys are dairy farmers. You know this answer normally. Or I want to show you that you know this answer. 10 million per year, if you think the world right now is declining with 10 million cows per year, you can now sit down. Matt Lucy is getting a bit nervous. Journal of Dairy Science, they should know. Okay, nobody sitting down? Okay, if you think that it's declining by 1 million per year, you can sit down now. Okay, some people start sitting down. All right, if you think it's stable, please sit down now. If you think it's increasing by 1 million per year, you can now sit down. All right. What would have happened if I had asked chimpanzees? What would have happened? 1/5 of them would have been upright, okay? Because 1/5 of them would have been still, by random, selecting the right answer. These are the people who are right. And that's only, how many? A handful. So in other words, this room is more stupid than chimpanzees. We don't know our own world. Right now, the actual number of cows, if you ask ChatGPT, it will give you the exact number. We are adding about 8 million heads every year. So every year, we are adding exactly the same amount of dairy cows as the US has to the planet. Wow. Fucking hell. And we don't know. Wow. You see what I'm trying to say is the data is becoming so overwhelming, it's available, and we don't know our own world. So I try to always do this, and this is, by the way, this number is not declining at all. It's already there since the 1960s. I got your attention now? Okay, we're going to make a switch. I promise. Ooh, where is my... Come on. Can you help me out? One more. So far, yes. Okay. So I asked this. So let's say that you guys are 150 people. I need to switch my my question. I've asked this right now to about 1,200 people in the world. All dairy producers, veterinarians. So if you see, this is Cornell. Then this is somewhere in Italy. This was in Ohio last week. This was at the ICAR in India. This was in New York. This was in Germany. I've asked this, and this is the general population that is right. You guys now, yeah, how many did we have? 6 on 150? So I'm just trying to prove you that we don't know a lot about, not a lot about our own industry. Okay, sorry for that. Okay, I need to talk about AI. AI uses data. I just proved that that we don't know our own data. So maybe, let's say, AI could come in as a new tool, and don't get me wrong, AI will not solve the world. But it might help in some of the things that we do. And I'm going to try to show you a bit. So all of these things, they are called AI, but it has really changed, let's say, when neural nets, when Google, Facebook, OpenAI, whatever you call them, when they started to heavily implement neural nets, and they were already doing that through machine learning, natural language processing, the ChatGPTs from this world, those are all, let's say, based on things that they discovered, but they didn't really discover it because they just looked at our own brain. I'm going to show you how, in fact, AI works. This is my oldest, Leon. Leon was born at a certain moment, and his brain was in fact what now Google has in a data center. It's a neural network, it's connections between neurons, which is in fact 2 input signals that eventually come out with 1 output signal. It's an electrical circuit that takes in 2 inputs, you connect them, and then you have an output in his head. The first thing that happens in a young mammal or in a young kid is what we call unsupervised learning. The moment that his eyes open, his eyes start scanning the whole world, left to right. And there's no focus. Why is it? Because his brains haven't connected yet. So the connections still have to be made. And that's what they do. They start looking at a pattern. At a certain moment, he will see that this is a chicken because he understands 2D, 3D, his ears work with it, and he starts looking at patterns. But nothing has happened as it comes to learning by the outside world. This is what in AI is typically called unsupervised learning. Today, AI can detect patterns that you would never be able to see in data by looking at yourself. Next, what I do is I will say to him, this is a chicken. Let's go to the chicken. So what I do in his head is I connect the name chicken to a pattern. This is what Google would now call supervised learning. I learn him that this is a chicken, so he understands that it's a chicken. The moment I took this picture, the next thing what happened, she turned her head and gave him a bite. This is what Google will tell, it's reinforcement learning. You learn your own system that you shouldn't be having your hands too close to the head. That's an automatic car. A car that learns itself to drive by feeding the output back to the input. Nothing more than that. So it's our brains that are let's say, the start of all of it. All right, an example of that training is this one. I always find it very funny. Who knows this? Yeah, please verify. So let's think it out loud. There's a computer asking you guys to verify if you're human. Really? What's the trick behind this? What's the reality behind this? Google had a big problem. You guys were storing pictures everywhere in the cloud, but you never said what was on it. So what they did is they said that they would make an agent, this one, and it would bring a safety to verify if you're a robot. And you guys all think that that's the reality, but in the back, when you click on the roads, what do? You learn their algorithm. The business model behind this tool is that you're training Google's data sets for free. Completely for free. Yeah, verify that you're a human, asked by a computer. Okay. I do a lot of that in my lab. So I have a lab which is using all different sources of data, farm management system, omics, biomarkers, precision livestock farming tools, sensors, vision camera, I will show you a bit of that. So that's all, let's say, changed into what we now say real world evidence. All of these things we do with a big team. So my team right now is consisting of undergraduate, graduate students all over the world, postdocs, that are working on some of these things. Some are more to the data science, some are more on the, let's say, the older way of looking at things. These are the new AI people. I'll show you something. There's definitely a hype cycle going on in agriculture and AI. You're going to be bombarded by companies claiming that they do AI on top of your data. I'll tell you in advance, 99% of them will fail because they don't have the background to understand what's really valuable there. The question is, where are we? Probably we're somewhere over here, yeah? Just by the technology trigger. To give you some ideas of what's possible, not so surprising, this was already done 5 years ago by my lab. So for example, we took the data from NEDAP sensors. So these cows, they had NEDAP tags, neck and leg. We used their sensor data. We created, this is the artificial intelligence network. And eventually what we try to do is predict whether the calf was on the ground. It's perfectly possible to do that. Not a problem at all. We created several models, one for within 12-hour prediction, 6 hours, 3 hours, 1 hour prediction. It's very easy right now to predict if an animal is calving from NEDAP tags. That's possible. Finally, we tried the same because from all of the cows in that study, we also had calcium values, and we tried to learn, Meike is a graduate student at Cornell right now, if we can predict hypocalcemia from exactly the same data using an artificial model. So the model would say this cow is at risk for hypocalcemia. Was it possible? Yes, 100%. It's possible. Is it good enough yet to use on a farm? Nah. Not good enough, but there's a lot of discussion about the label again. But this is going to happen, but we're not there yet. It's almost impossible to have good prediction models anywhere in the industry that are predicting disease. All the sensor companies, whatever they are named, whether they're Dutch or not, none of them can predict disease at this moment with the right amount of accuracy that you guys need on the farm. And that's because their positive predictive value, negative predictive values are not good enough at this stage to be implemented on farms. And this was the same in this study. And this is a very strong message that I sent, but I honestly mean it. Yeah? I don't say that it's going to happen, but the problem is especially that our data sets are not big enough to do this at this moment. The funny thing is that AI will learn us new insights. To give you an example, in our study that we had body condition score and locomotion scores in our hypocalcemic model prediction model. If you look into all Journal of Dairy Science publication when it comes to hypocalcemia, you would almost certainly find that at a certain moment body condition score and locomotion scores are positively associated with the risk of, or negative depending on the direction you look, with hypocalcemia. The funny thing is, if you give AI also all the sensor data, suddenly these features completely disappeared from our prediction model. They were not able to really bring value to the prediction. AI will learn us things, and I will give you another example there, that we overestimate. It's not because there is an association that there will be a prediction possibility using that feature. And that will trigger new ideas in our industry about prevention. And I think we should start getting prepared for more of that. This is a funny one that we just did. I got a small grant from Atkinson. So we are able right now, just by using open toolkits from, let's say, OpenAI toolkits, we ask very simply to the graph, to the satellite data, can you identify all the dairy farms in New York, CAFO? And right now, because the satellite data is open, and we have an algorithm, I think within 2 or 3 weeks, we had the entire pipeline ready to find any farm, CAFO. But think about what is going to happen if people with bad intentions are going to use this. Because it becomes also possible to do the following. This is a satellite which measures methane. You see it? Open, publicly available data. We were about, Jeff Bezos from Amazon had invested 80 million in a satellite that would measure methane around the globe. And we had written the grant because we wanted to be sure that when people were going to look at that data, that we had an answer why some farms were exhausting more methane versus the others. Because this is going to become, let's say, a threat to our industry because people will misuse it. Problem is, the satellite is gone. 80 million is gone. They don't know where it is. They lost connection, and they're now finding new partners. Google was also invested in it to try to launch a new satellite that will measure methane, but you see that it's detectable on a farm. This is a dairy farm. Of course, you see this is the flare. Not so difficult. Our idea was, can we find out how these farms, or whether these other exhausts over here, for example, is this buildup from the dairy cows, or is it also because of the wind direction? So we don't know. What else is possible? This is a Dutch project that I still run. This is a farm with chicken. And what we can do now, by looking at the satellite images, we can look, for example, at the orientation from a farm and then see whether the wind direction combined with the orientation of the farm is a risk factor for some disease outbreaks. Think about AI, not artificial intelligence, but avian influenza, whether it spreads or not from farm to farm, depending on how it looks, how the farm looks. This is hot. Everybody's looking at cameras. Almost all the sensor companies are looking at cameras. We are doing the same. This is one of my older projects where we were looking at drinking cows to detect whether they are drinking, yes or no. We're going to create a bunch of phenotypes as soon as we can and try to predict what animals are doing from cameras. This is one that I still run as well. This is using a Facebook model where we try to predict, or not predict, but detect automatically what the animal is doing. In this case, we tried to read if the animal was playing or not. Play behavior is something which is related to welfare. To give you an idea, the coloring is nothing more than a Facebook model that was open sourced. For those people who are knowing this, this is a SAM2 model. Okay, if it's hot, yes. RP, thank you for again selecting our students. To give you an idea, these two students, they pitched an idea to read calving animals, or to predict, let's say, to give a message when animals were calving, reading cameras, and they won the Evonik and RP Nutrients award last year at ADSA. This is clearly going to happen all around the world. People are coming with camera solutions. So definitely the trigger is there. The question is, what did we learn from the data world? Yeah? Because we had the big data hype cycle, which is something that, let's say, 10 years ago was going to solve everything, but we're still not there. First of all, what do we need to still focus on? Data integration is key. This is a farm in the Netherlands, Lely, I think this was cow manager, and then this was their herd management system. To give you an idea, the farmer refused to even have the computers talk to each other because they would just start blaming each other when something was wrong. This is Kirk, the university farm at Cornell, 1, 2, 3, sorry, 3, and then there was a fourth one over there. It's everywhere the same problem. And it's not because there is somebody that is now uploading an Excel file and then bringing it to ChatGPT and saying, look what I can do, I can now ask questions to the data set. That's not going to solve the problem. Yeah, we will need to have more integration projects than we have right now. One of the tools that I have been working a lot with in the past is an integrational tool where we would upload data from the farm, whether they had dairy comp or whatever source of data that you can think about. We would upload it to the cloud. Then we would create an API around it, add data to it, whatever you can think about. The funny thing is that I've used this data set over the last years a lot to have students work on it in an anonymized way. And from that anonymized way, a data set, they can add data to it. They can then create models. Whatever you can think about, it's funny. You can, let's say, the possibilities are humongous. But ultimately, of course, we want to have decision support with that. How stupid as it might sound, identification is a must-have, not a nice-to-have. I think some of you might know Catalyte that was acquired by GIA. One of the biggest struggles they have, and I think that's why it was good that they were acquired by GIA, is because they were looking at the locomotion score of the animals, but they had no idea who it was. And because there is an integration with GIA now, that will be easier. Because it's nice to know that somebody's lame, but if you have 1,000 head dairy, you need to know who is lame. I know there's a farm in New York who did the trial with Catalyte, and eventually they said our herds manager is faster and is more accurate in predicting who it is, because he reads the tags. And this will change. But identification is something that is overlooked so often in our industry. Lely, as soon as Catalyte was bought by GIA, suddenly Lely started installing Lely Zeta. That's their camera system that would solve everything. But what they especially wanted to do is block the market from other people coming in with camera systems, because they wanted to be sure that the hardware, there was vendor lock-in by the farms on their system. What they are going to do is trying to predict who is, or that somebody's calving, but not who is calving. Again, the who is important. See, 65, 66, that will give us some challenges. Being able to predict I'm sick, calving, or lame is not good enough. You need to be sure who I am. Don't forget about it. If somebody comes into your farm and says, I can do this, 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 and this, ask immediately, can you tell me who it is? Always ask. Never forget. And you will see how they will back off. Okay? And don't just listen, also make sure that you see it. One of the funny things that we've been doing, we've been taking pictures from farms, from calves that were born until they were milking, and what we see, because the pattern of the animals is something that you can use to identify. We know that that's working, but the funny thing is we now see that some of these patterns are changing over time. We're going to have some graduate work on trying to see if we can learn something from that pattern. We will need a lot of this. Standardization. ICAR, I'm head of one of their working groups, IDF. We recently did a review for Journal of Dairy Science to try to come up with standards for sensors. If there's one thing which is completely blocking the industry, is that all of the commercial sensor providers, They are scared like hell that they would lose market by just becoming comparable. There's a 1 hour difference in rumination time on tags that you put on one cow, 2 different systems. 1 hour difference. For you, it doesn't matter because you look at the deviation and your farm runs on it, let's say, smoothly. But we cannot compare it, and what we would love to do, of course, is bring those data into breeding programs. Rumination time will tell us something, but right now, a NEDAP versus a cow manager versus, let's say, the AFI tags are completely incomparable. And that's something that we will need to do very soon. There's one of the people here, Jeffrey, you probably know him from Hostens, USA. He has been doing a tremendous amount of work in trying to show that, but of course he gets backed off a lot by commercial companies. They hate it to work with him because they are scared of comparison. But think about what we want to do in the long term. Is that what we want to do? Yeah, is that how we want to be named, that we're not collaborative enough? Okay, so I hope you get the message. We need to shift. We also need to shift in our academic world. This is an example. We did some studies with one of my graduate students, Jong-Jan. We looked at, I'm going to show you this. Yeah, we looked at lactation curves. I have a lot of work being done on lactation curves, sorry. And what we especially want to learn is how this lactation curve persistency is changing when animals become pregnant or when animals are inseminated at a later point. I will spare you the details, but what I want to show you is what happened when we did the review process of one of these things. So what we did is we tried to predict at 50 days in milk, 75 days in milk, 100 days in milk, whether an animal was going to be persistent or not. That's a prediction model. We did this and published this, and the funny thing was we found very bad results. Yeah, our model did not function at all. R squareds were low, to moderate, let's say, low. But in other words, what we were able to say is look at what, even at 125 days, given all the data that we know from a farm, it's not possible to predict the persistency. It's a lot to do about reproduction and short calving intervals, those are details. But what's the funny thing is that the first iteration that we had is the reviewer said, your results are bad, you shouldn't publish this. And this is the shift that we need in the academic world as well, because it's not about association anymore. It's about prediction. But the reviewer struggled as well to just understand, because we are all trained as frequentist statistics, and now suddenly this AI machine learning comes in, and they said, yeah, but you shouldn't publish it because it's bad results. Well, it's important, because the message from the paper is, you guys in the field right now should not have long calving intervals, because we cannot predict with the best of our AI tools and whatever, what an animal will do when it comes to its persistency. That's a very important message. But the problem is that also the academic world needs to adjust. Okay, and then on top of it, there's a graveyard of academic models because science rewards novelty over sustainability. I am rewarded because I do something for the first time, not when it's something that somebody else has already done for 10 times. Would you trust a new technique that has only been proven once, or only when it was proven 10 times? What would you do? You would wait until we have some more proof. See, so this is a bit of a strange thing. I'll show you some first signals that it's not going in the right direction. And I don't know Matt, if you ever heard about this article and if Elsevier ever corrected it. So at a certain moment, in the beginning when ChatGPT was there was a publication done in radiology case reports. Has nothing to do with cows, but you'll see why I show you this. So this is Elsevier, which is also publishing, for example, Journal of Dairy Science. And at a certain moment, in the summary, it said, in the summary, the management of bilateral iatrogenic, I am very sorry, but I don't have access to the real-time information or patient-specific data, as I am an AI language model. Elsevier, people. Editor, reviewers, all of them didn't see it. So ChatGPT was used to write the article. There was a case report recently from a journal paper in Animals and Animal, and the original article was pushed through ChatGPT, completely rewritten, and in all the tables, they just changed 1 decimal. Because I am pushed to increase my publication output. Cornell will tenure me if I have enough publications. You see the tempting part in that? And this is happening, eh? I use ChatGPT. I use it. We know it. So, but it's going to change how we look at the world, but it's also going to, we will need thoughtful people to think about how we're going to manage this. The output that we're generating in journal papers will increase, especially if we think about competing industries, let's say, competing countries, where, let's say, the output is still a metric. They have interviewed the 10 people in the world that have the highest output possible. 9 of them didn't react. See? That tells us something. Okay, but what do we need to do it better? I'm going to show you some nice things that we're doing at Cornell right now to try to not make that deep pitfall and try to get to productive things. This is not easy. I'll tell you in advance, it's not easy, but I'm going to show you what we're doing. One of the things that we're doing is I have quite some people working right now about production analysis. Okay, what can we do with AI? What you need to know about AI models, it's more than just creating the model. But to give you an idea about how complex this is, if you look at 305 production, right now, the model in the US has been built in 2000. So for 25 years, we're using models, and they did not change. Did your cows change over those last 25 years? Yes, they did. A lot. I hope they did. But we're still using what was done at USDA, Best Predict. It's still valid. But think about the disconnect. We're saying that AI will solve everything, but we're still using something from 25 years ago. In Dairy Comp, the 305 calculation, was it ever updated? I doubt it. Do our lactations change when we look at it? I think they did. To give you an idea, in the Netherlands, the model in the back is from 1980. I contacted Hans Wilmink recently. He's now running marathons. He's in his 70s, running marathons. And CRV is afraid to touch the original code because they don't have programmers anymore that are able to change it. So we're still using something from 45 years ago. And it's still good and valid. And I'm not saying that this is bullshit, but I'm saying that there is a disconnect between what's going on in the real world and what's going on, let's say, in the thinking that AI will solve everything. What we've done right now, and I'm going to show you the process and the capabilities and the things that we're trying to do on top, is work. It's already almost 10 years old as well. So Arnaud was working with me some years ago. He was quite fond of neural networks. Mieke is now working on top of it. And what we did is we created a basic model that is better able to, let's say, predict milk. And what it's based on, it's in fact based on tensor theory, which is a technique that's used by Google a lot. But what you should know is we said all the data that you have available in Dairy Comp or whatever system, and it has the milk yields, all the events, all the herds, let's say the other cows in the group. The algorithm could use everything from about 100 farms and then create an AI-driven digital twin. A digital twin is in fact a representation of exactly what you guys are doing, but in an AI world. We did that, published it, and it works. To give you an idea, this is an example of it. So the green are the milk weights from that animal, and at a certain moment here, it stops being observed, and then what we do is we let the algorithm predict how the rest of the lactation will look like, and that what you can see is that indeed, let's say, the average follows quite accurately what is happening. AI will change this completely because we will be adding more data on top of it, and it will become more and more predictable. The funny thing as well, after, for example, a perturbation, that's, for example, this dip, yeah, this is where an animal probably got sick, we're quite accurately able to predict what's going on. This is the base model that we've been using now for quite some time. This is a CNN, for those people who are interested. But because we had all the information from those 100 farms, quite detailed information, what we now can do is we learned the model how to work with all the data around it, which sounds quite technical, let's say, but what eventually the model learns is it can accurately look at the actual milk yield from an animal, and then you can reconstruct the animal as if it becomes older. You can simulate as if it becomes older. So AI can learn what your animals do on your farm when they get older. And that will be different from your neighbor. We know that. We know that if on some farm, if you look at a treatment effect, that it differs with your neighbor. And so many consultants, I think in the room, Mike, you know this as well, that it's so interesting to think about why did I do this on this farm and I raised my milk production, I do the same thing on his neighbor and there's no effect. And that's where AI will help. AI will help to untangle those complexities by creating, for example, digital twins or whatever you can think about. This is a lactation curve of an animal where we said, look, predict as if the animal was on the original farm, but you can say, bring this animal, bring it to the neighbor, and look at what his milk production would look like. You see the possibilities coming? You can think about reconstructing with or without mastitis. And the nice thing is, we get rid of the frequent statistics where we know that we had issues in determining how big the effect was because we had that lactation stage effect. Now we can do that and learn across farms, with or without disease. This model was eventually now used in a follow-up application where we said, let's use this model as a base model and try to predict what animals are doing in the beginning of lactation. A bit of the TCI idea. So we used the original model and then started predicting in very early lactation milk yield. And our models outperformed some of the, let's say, baseline models by having a better prediction accuracy. So we're getting closer to getting a better decision list. What are the animals that need attention tomorrow? They were milked this morning. Which one deserves my attention given everything that you know from the animal? So we're moving into that direction because you could use the residuals. Yeah, so the residual is in fact, so what we can do now is we can predict this line in the beginning of lactation quite accurately, and then we can say this animal is producing more than we expect, so the more than expected or less than expected. And the negative ones are of course the ones that deserve attention, potentially. We're getting there. We did the same. Matthew published this for milk recordings, so we have a model for milk recordings as well. But then what we did is think about, can we make sure that this model is also reflecting what we see on the farm when we look at the animals? So we did a completely different study. We had the original herds that were used for the model, and then we went to a research herd, implemented the model and looked at the blood metabolites in the transition period from these animals and checked whether what we saw was also validating our thoughts biologically. So what we saw is that the residuals, if the animal was producing more or less, was, for example, and not so surprising, it was positively correlated with dry matter intake postpartum, not prepartum, which was strange, but again, that provokes thoughts. We had all our metabolites in there, and one of the funny things, for example, is that we were able to find, and this is things that we know that live in dairy science. But for example, we found that cows with high NEFA, so they are mobilizing a lot of fat, and a high intake, they produce more than expected. Cows with low NEFA produce as expected, regardless of their intake. And this is something that people has always said. Those cows that lose body weight, but they keep eating, they produce more than expected. If they have low NEFA, so they're not mobilizing, then regardless of their intake, milk is exactly what you predict. You see, we start understanding the things that some of the researchers observed already, but it brings new hypotheses to life. Okay, last, an example of it. We did exactly the same modeling that I just showed, and then we had also from all of these animals, we had a big study in which we had sensor data available. So we had, from each cow, we had the number, are we producing more or less than what we predict? And we had sensor data. Who has seen this graph? This one. Resting time is positively correlated with milk yield, milk production. Everybody's using that graph. It was never published. It was an abstract somewhere in a conference, but it was never really published. Because I think if you started looking into the details, maybe it was not so valid, but everybody's using it. Everybody's using that graph. And we had a tool now, because I was able to say, okay, from 8 farms with a lot of behavioral data, I do create that model where I have the prediction whether they're producing less or more than I'm expecting, and then I had lying time in my model. And to give you an idea, this is the result. So cows, low MRT, medium MRT, or high MRT, that means are they producing more or less than expected? The lying time between those groups was exactly the same. Once you start correcting for everything that we know on the farm, there was no difference in lying time. Do I say that lying time is not important? I'm not saying that. I'm especially saying that maybe we looked at it way too in a univariate way. Just making a scatter plot and drawing a line is not enough. Because if you're lying down a lot, you're not eating. So there's probably something that we need to learn. My graduate students are right now working on how can we learn from that interaction, because of course what we see is that the rumination time between those groups is completely different. So cows who are producing more than what we can predict are ruminating more. That's what we expect probably as well, but the lying time was not different. It was very surprising in the beginning to start digging in because people wouldn't believe it. Okay, Miel, this is all very interesting, but how in the world are we going to use this on farms? That's the next problem. Because at a certain point, we have all these complex models, but you guys, you're not waiting for another screen. Okay? We're working on it, I promise. And Iker had a good idea. Maybe Iker was already a bit like ChatGPT, Chat Iker. Because what did he build? He built that stupid command line. And it was, from that perspective, you guys loved it. But ChatGPT, of course, made it better. Because now, you don't need to call Iker because you don't know the command. We can start thinking about, can we make something which is more stupid proof? Sorry, I didn't call you guys stupid. I called you chimpanzees, but I didn't call you stupid. But what I want to say is that the whole world has changed, and we did this recently. So what we did is, this is a postdoc of mine, we added the functionality of large language models. And so for example, what we can do now is we can talk to the model. Because ChatGPT, I can connect it to my model and say, in natural language, I can even ask, can you show me can you show me in natural language some things that I want to understand? We are working right now on a project that was NSF funded, where we want to say, can you please compare my lactation curve for my cows to all the people in, for example, so many miles around my farm? Can you see if the effect of an aging cow is different on the farmers around me? Because that's where you will learn. You want to understand that. And we are there. We published this as well, but there's a new problem, and that is ChatGPT is only built on everything that is available. So in other words, there can be misinformation there, and misinformation can be a weapon of mass destruction. There is some ideas there, so I asked ChatGPT, is having an older aged herd of dairy cows more profitable? I asked it, I think, a year ago, and what you will see is that the last thing that it says is older cows may already have passed through periods of higher susceptibility. What it says is in fact not what we biologically expect. Yeah, we would say older cows are more susceptible. Okay, so somehow ChatGPT learned the wrong thing. So we said, okay, let's do something here. So PubMed has all the Journal of Dairy Science abstracts available since what was it, Matt? 1620? So I had a postdoc, and people of Journal of Dairy Science, they probably had a rough night at the service because our tool was scraping all the abstracts for over 100 years. So we downloaded everything as an abstract, and then what we said is, let's use the model that was pre-trained by Facebook so that we understand how people talk, but now you add all the knowledge of Journal of Dairy Science on top of it. So it now becomes more smart. We have now a proof of concept. So for example, you can ask what feed additives can be fed to reduce methane output. And what this is doing is it will also know what was published in Journal of Dairy Science, and it will even give you the references that it used, the top 5. Because people need trust. Yeah? We're going to do this for many other journals, thinking about other domains to be added. This was published last year together with Mike Vandehar, who's president of ADSA at the moment. And you can use the tool, although it's not very stable, but you can use it at the portal from our lab as a proof of principle. But sometimes it's a big, because I'm not willing to pay a lot right now to have it being tested all over the world. That's why it's sometimes a bit crunchy, but we're building on top of this. So you can have then this kind of a Bovibot, and then it answers, because it will build trust. We're now building a new tool with NSF money that will allow us to do exactly what you just was talking about. This is also published now in Journal of Dairy Science Communications, where we will leave the data on the farm, but bring all the knowledge jointly together in the cloud. So your data will never leave the farm anymore. But you will be able to talk with your neighbors somehow. This is an NSF-funded project that we're working on. One of the first things that we're trying now is these are all models. What we want to be sure is we want to learn if there are models that would work on your mobile phone. Because I know that most of you don't always have good reception. If you don't have good reception, you cannot use ChatGPT. But there are solutions for that we're looking into to try to see if we can talk to farmers. Okay, last few slides. We are not there yet. Who owns all those models? If it's federally funded, if it's a multi-university, what is the value of that? Are you guys ever getting anything back from all that data? Should we open source everything by default? How many of the published models make it to real-world implementations? Almost none right now. That's a real problem. The insights, they reach the industry, but the models, they don't reach the industry. How do we transform this? Those are questions I need to ask, let's say, in the near future. Ask myself. I hope I got you little bit, one, entertained, two, into AI. If you want to follow us, we are on probably all the platforms that we need to be. This is the lab's website. You can reach me at the Cornell email. A lot of thanks to all the people who have contributed over the years. This is the oldest and the youngest. They're a bit older now. I hope you guys understand that it's important for me, those two. Those two need to be there on a healthy planet. All of what I do is related to that. People ask me a lot if all this AI is not using too much energy. Yes, That's also a problem. But if you want to know the comparison against a cow, go home and ask ChatGPT. And you will see that indeed, if you use ChatGPT a lot, the average consumer, yeah, it's almost the same like drinking a latte, I think, a day. That's the same amount of equivalence. If you use ChatGPT versus drinking milk, people are comparing that, unfortunately. Don't be afraid of it. It will come, and I'll take any questions.
Do we have any questions for Dr. Hostens?
There must be. Don't be shy. They are shy. They want to ask ChatGPT. Yeah, that's also good. I'm okay.
Right here.
Can never let a speaker get by without a question. But would a company like Valley Ag make all of their cow data open source with anonymity?
They won't. They won't. The good thing is, you guys own the data. Valley Ag can do anything they want. It doesn't matter. Think about, make it the very simple comparison. If you write a document in Word, who owns it? Bill Gates or you? You own it. Of course, the companies are trying to make the access to it difficult, but never give me something that's difficult to access because I'll try to find my way around it. As long as the farmer wants it, you can get it. And that's the good thing. But of course, everybody wants to be now the next Google. That's in dairy. Will Valley Ag win it? You need smart people. They are thinking about IT-wise, business-wise. It will be probably a collaboration.
So I have a question, and I'm going to try and word this the right way, but I've read where the open source AI bots are scouring the internet, grabbing information from everything that's ever been posted, but the more people use them, the more the responses are actually from the AI bots, that they are actually creating a loop.
Yep, that's reinforcement.
Is there any danger of that with animal ag data?
Yeah. Well, there's a pro and a con. So if you ask ChatGPT now something about your farm, something that you want to do, you will get a general answer. The moment that you would add your own data to the loop, it would be a more specific answer that is able to be given. That's what we are working on. Can we allow the farm to have all his data and keep it with him, while he does have the ability to learn from it? That's what we're doing. Of course, if you think about the fact that it will start using that data then for the bigger, yeah, you can guide. If you ask right now the Chinese ChatGPT, let's say, version, it will give you wrong answers on some of the things that happened on the, what is it, Tiananmen? So think about the fact that you start influencing it. Look at what happened with Elon Musk, his AI tool, where it was generating naked pictures. The thing is that it should be democratized, where people have governance, because otherwise it will go wrong. You can be sure about that. And look at what happens with elections. These tools are so powerful. So I think, yeah, but we need some governance there. I hope also at JDS we have a role somehow to play with. How do you govern this? Elsevier has a role to pick up. Can you detect that it's happening? I don't know.
Very interesting, fascinating talk. So as you showed that AI hype curve, or whatever you call it there.
Hype cycle.
As you see that develop, and so you kind of get that spike, and then you drop down, and then we hit reality. And so there's many endless opportunities that we see here of things that we can go after. So as some of those simple ones that we could really be valuable now in the next few months, years, whatever it could be, very soon, I say the low-hanging fruit, so such as your milk yield predictions and taking those and implementing those, what are some of those next steps to actually seeing that taken on to farm?
Yeah, so this is the one that we are doing right now. So the idea, what we're trying to do is the following. So what we're trying to do is you have a research farm where we get insights, you train a specific model, it goes to, let's say, an R&D, Cornell cloud, whatever, and then what we are able to do is the idea is that we will be able to inject this as soon as possible to some test farms to see if they are getting better predictions for whatever you can think about. This is the one that we're trying now, to exactly shrink in that time. Remember, the models that we used were 20, 30 years old, trying to get that sooner to the farms. How fast this is going, NSF looked at this dairy use case and they found it very interesting because there's not a lot of use cases where they can try this. The same one, we want to have camera models here because you don't want all the video data to be sent to the cloud. Because imagine that ICE would suddenly demand that they get access to all the videos from the farms. You see the danger in that? Yeah. So they are thinking about, can we try to get the insights from the camera to the cloud, but not the video data to the cloud? Because people are afraid of that. Farms are thinking about that more and more because they don't want to imagine that suddenly somebody demands access to your video data that's stored in the cloud, and then they can. And what are the examples right now? I think cattle care, where they're milking the milk, their camera, having a camera on top of the milking parlor, so you know everybody who's milking. See the danger in that? Privacy-sensitive information. So we're thinking about how can we work with that, but still you want to learn from that process. So it's something that my whole team is working on it. Low-hanging fruits, business models need to be also changing. Yeah. Go ahead. There are definitely people like Cadli is, I think, one of the first who tried to look at locomotion score. De Laval had their BCS camera, which is completely going to be changed into an AI system, 100% for sure. There are others, the cattle care system we know. There's some neat, let's say, startups coming, but Everag, you probably heard about that. They had at a certain moment Caintus. Caintus had the idea to put cameras on top of the feed alley, and then they were going to predict individual intakes from cows. They were owned at a certain moment by Cargill, and they were sold for $1 because they made so much profit. It was not working at that time. It was 5, 10 years ago. But the thing is that there's a lot of over-promising. Right now, what Caintus can do with Everag is they can tell you if the feed bunk is empty or not. So they scaled it down. Instead of individual dry matter intakes, they now said when were the push-ups being done. It is also valuable. But is it that valuable that it's worth an installation of all the cameras? There's definitely a lot of camera tools coming. NeedUp now has launched in New York a camera system for locomotion detection. It's all going to come. If I look at the average farm size in Georgia, you're also not that high. That's, I think, a lot of smaller farms. I don't know if you have a lot of robotics. I guess that all of the Lely, De Laval, GIAs, they're going to implement some of these camera systems on top of the robot. Will it help? Definitely. But watch out for the overselling. Watch out. Over-promising. That's what I would definitely advise. Make sure that you see it and visit somebody that uses it all the time. That's what I would always advise. You can, as long as they allow you.
If you're going to ask ChatGPT
I'll repeat the question in a minute.
Assume that your wording of that question determines its outcome. So if you want to have the most accurate answer from them, do you have any suggestions of how we ask that question?
The prompts. You can learn that even from ChatGPT. If you ask ChatGPT, how can I ask you the best questions, it will guide you in that. It's that stupid, let's say. I would say learn it from them. I wasn't a big user myself, but I'm surprised over the last months when I started using it more for stupid things. Like I came into this room and somebody said, how big is your dairy industry in Belgium? And I was like, damn, good question. So I said to ChatGPT, can you give me a table with the square miles, the number of dairy cows, and I asked it that and compare Belgium to Georgia. 10 seconds and I had the end. That's how I did this trick. And it brings you in a table. To give you an idea, yesterday I put in 10 of my accountant's reports and I asked, can you extract that number from each of the reports and bring it into an Excel file so I can start analyzing it? Boom. People are working on statistical agents that will be able to tell you, can you tell me if my milk production on my farm is significantly different from last month, for example? People are working on that. The speed at which we're doing this is incredible. Ask the question and you'll see it right now. That's the good thing because it learns from you as well, and it will even tell you, like, I cannot do this, but please, if you tell me a bit more like this, this, and this, I will give you a better answer. So it's incredible. It's scarying how good they understand the world. In the beginning, people were skeptical, but it can do amazing things. I was in New Zealand, and what I said is, look, I'm going to drive. I had a friend who died 20 years ago in New Zealand, and I said, look, I'm here. Can you drive me to that place and show me the nicest places to visit and to have a drink? And within a second, I had a Google Maps with all the right addresses, incredible. But you need to use it, and then you'll see it. But of course, indeed, it's scary because if you think about what's going in, yeah, let's democratize it. Let's hope that democracy wins and that smart people are able to govern this and that nobody misuses it, but it will be used against you, that's for sure.
I think that's a good one to end on. How about a round of applause for Dr. Miel Hostens?